Hi guys, Buildzoid here, and today we're going to be taking a look at my very small and adorable weapon of choice for the Gigabyte March OC Madness competition. So there's only 10 days left in the first stage, so kind of in a rush to get this one, and actually thanks to all the Patreons for making this acquisition possible, as I will be using this for all the Gigabyte competitions upcoming, and you'll be seeing it in streams a lot, as well as there will be a full review up on the blog of this board, when I get around to doing that. But yeah, so today we're going to go over the reasoning why I chose this, as well as the VRM spec on this, just because the heatsink's already off, so it was really easy for me to figure out everything on the board. So the reason why I chose this for the March OC Madness competition instead of, say, a ATX board or an MATX board with a real VRM, not this 1, 2, 3, 4, 5 phase joke, is because this has 2 memory slots, not 4. And that is a huge deal. Basically, the reason why I chose, well, the March OC Madness competition is 5 GHz limited. That means the CPU is not allowed to go over 5 GHz CPU core clock or uncore. Which basically means the competition is memory clock focused, because, you know, KB Lake 5 GHz is very, very easy to do, and that means everybody in the competition should be able, well, basically everybody who turns up with an i7-7700K is going to be running 5 GHz. So you can't win it by just brute forcing your CPU to 5.6 GHz on water cooling at completely unsafe voltages. This competition requires a little bit more refinement than that, and most of that is focused on memory overclocking capabilities. And the benchmark selection for March OC Madness also reflects that, as we're looking at 3D Mark Time Spy Physics, Geekbench 3, HWBot X265, and Intel's XTU. All 4 of these benchmarks scale well with memory overclocking, as in they reflect memory overclocking improvement, like performance improvements from memory overclocking, a lot more than, say, something like Cinebench, where plus minus 400 megahertz on the memory sometimes won't make much of a difference. So the benchmark selection is very much memory focused, and the 5 GHz CPU restriction basically means it's all about the memory overclocking. And 2 memory slots give you a huge advantage in that, because basically the main reason why 2 memory slots is better than 4 for memory overclocking is this outer slot, is closer to the CPU. And actually, even this inner slot is closer to the CPU than if you had 4 memory slots. And this shorter, slot to CPU distance is actually such a huge deal that Gigabyte has special edition LN2 motherboards, and one of them significantly violates basically the motherboard doesn't come with any mounting holes for coolers, because they shoved the memory slots so close to the CPU socket that those no longer fit. There's nowhere to put mounting holes. So that, distance improvement is a huge deal, and this motherboard actually also reflects that in its DDR4 support spec sheet. Basically, it supports DDR4 4000 officially. This is one of the few Gigabyte boards currently on the market for Z270 that supports it. As far as I'm aware, it's the only one that supports DDR 4000. So that means this board should, in theory, overclock memory better than any other board anybody turns up to the competition, because all the Dash LN2 boards are banned, because you can't buy them. As they're non-retail, the only way to get them is to basically know somebody at Gigabyte and also be, a world-class overclocker, because otherwise Gigabyte doesn't see a reason why to give you a board. So basically, I chose this because this has memory overclocking. It should have better memory overclocking capabilities. I will try to test that. I am not the best memory overclocker. Actually, I'd say I'm probably one of the worst. I'd say I'm like beginner level at RAM overclocking. If I was the worst, then it'd be a case of I don't even know how to tweak timings, I guess. But it's not like I'm very good at memory overclocking. So I will try to test the memory overclocking capabilities of the board to the best of my ability. I hope that just my selection of board just is an unfair advantage and I have a very easy time running memory settings that none of the other Gigabyte boards can manage for the March Madness competition, but I think that would be kinda in the realm of dreaming, not in the realms of reality, especially considering my memory overclocking skills. So then, let's take a look at the other parts of the board, which are actually a massive letdown if I was doing anything other than a 5 gigahertz limited competition. First of all, VRMs. V-Core VRM is 3 phases, and it's using 4C10 and 4C06 MOSFETs from On Semiconductor, and that's actually like I'm shortening the model number because the full model number is long and ridiculous, and if you just punch into Google 4C10N, it'll come up with the correct MOSFET, and if you punch in 4C06N, it'll come up with the right MOSFET. So the rest of the model number doesn't really matter to me, and it's easier to just keep track of them this way. So anyway, these are pretty cheap, pretty miserable MOSFETs from On Semiconductor. The high side FET is the 4C10, and those have 7 milliohms of on resistance, and that is at 25 degree, like that's at low junction temperature. If you actually have these MOSFETs running under full load, then they go all the way up to 1.6. Basically, the on resistance increases by another 60%. So they aren't really, like, they're not horrifically inefficient, but they're not incredible MOSFETs. Okay, they're very much a sort of budget part. The 4C06 is similar, except it's not viable as a high-side MOSFET. Well, actually, that one is a 4 milliohm, so, you know, significantly lower on resistance, but it's not viable for a high-side MOSFET. And it also has that 60% increase when it gets really, really hot. So when you're running it towards the limit of its capabilities, as in the junction hits 150 degrees, which is the absolute maximum temperature that the MOSFET's internals should be operating at. Above that, you know, you start running into, well, it becomes very likely that the MOSFET will degrade and then die. So, yeah. Either way, with this MOSFET setup, which is actually on the front of the board, you can only see 6 MOSFETs here, but in total, that VRM is actually, the V-Core is made up of 9, as there are extra low side MOSFETs on the back of the board, and I'll try to get the glare out. So I have these 3 right here. And that means that in total, the V-Core VRM is capable of delivering about 102 amps, and that's limited from the high side MOSFETs, as they really are the weakest link for that VRM. So you're capable of 102 amps at 125 degrees operating temperature, so very, very hot. If you have any airflow going over that VRM, or if you even go and, you know, figure out some way to put a heatsink on there, you really shouldn't be getting anywhere near that temperature, and so your current allowance will be much higher. Either way, 102 amps is good enough for Kaby Lake overclocking on air cooling and water cooling. Not custom loop, I'm going to say AIO. Because Kaby Lake, generally for like 24/7 usage, you're going to be aiming to keep the current draw below 45 amps. I mean, 90 amps, sorry. Not 45, 90. So current draw below 90 amps, so that 102 amps at 125 degrees, assuming 300 kilohertz switching frequency, is actually perfectly fine for daily usage. It is not enough for LN2, though arguably with an LN2 pot, you might be freezing the entire motherboard just because the cold will pass through the socket and into the rest of the board. So actually the VRM might be running so cold that even though it's not great, it would function with even in LN2 overclocking scenarios, but that'll be an interesting test to do. I'll probably end up having to stick a thermal probe into the VRM, and when or if I put this board on LN2. I think it's more a matter of when, as I do plan to use this board for the entire Gigabyte overclocking season, and there are LN2 cooled competitions coming up. So I'm not going to be buying another board for those. I'm just going to use this again. So we shall see if this lets me down later on. But I think, you know, it's borderline, but it should be enough, especially if I can keep the temperature down, which with LN2 is really easy. With air cooling, you know, just get some airflow over the VRM. look into getting a heatsink. Now, for the iGPU, we're looking at the same MOSFETs, but less of them. There's only 4, and they're in 2 phases. So you have 4C10s and 4C06s. This VRM up here is capable of doing 62 amps at 125 degrees, 300 kilohertz switching frequency. The memory VRM is right over here. It's a single phase, and that is, again, the same MOSFET, so 4C10 and 2 4C06s. So that works out to 34 amps for your memory, which is plenty, which is actually ridiculous overkill because DDR4 runs very, very low power at high voltages. So that's really not a problem, that VRM right there. I would prefer to maybe see, a 2-phase for power quality, or maybe more capacitors. And actually, that's another concern that I have with this board, is just like this capacitor bank is really, really small. And also, interestingly enough, the location of this capacitor bank means that if you, I have the AIO I first tested this motherboard with was the Sadon 120V. And in certain orientations, this capacitor bank will actually bump, interfere with the mounting of the heatsink. So that's something to keep in mind if you're using this board, that you actually have to check your thermal paste. Like, put the heatsink down, pull it up, see if the thermal paste spread properly. If it didn't spread properly, then you have to try a different orientation. If it did spread properly, well, then you got to reapply your thermal paste because you just ruined it. But then you just put it down in that same orientation and you're good. Because the first time I tried mounting this, I was wondering why I was hitting 100 degrees with a 120mm AIO, and then, then I rotated it, and that capacitor bank was no longer interfering, and everything worked great. So, yeah, that's one concern with this capacitor bank. The other issue is it's really, really small. So, I will be... I do plan to mod this motherboard after I have all the scores I want for at least this first competition. So I'm going to be adding extra capacitors. I might end up completely replacing the V-Core VRM with an E-Power. The problem is I'm not sure if that'll interfere with the iGPU VRM. And if it does, then, that's a real problem, as I'll have to replace both, and that's a pain to do. So ideally, I don't want to have to deal with that. So hopefully this is just enough to run everything. And maybe the extra capacitors will help run lower voltages, as they should help clean up the power. But, we'll see if that actually works out the way I wanted to. It might not. So, yeah, other than that, for I/O, I mean, you can check it out yourself. There is a USB Type-C. On the back of the board, you do have an M.2 slot right here. Not that I care about that. The PCIe slot has the steel armor. I actually like that steel armor. It's nice. It looks better than just plain PCIe slots, and it does help you from ripping out the, slot out of the board, which with some of the cards, it's really hard to reach that clip, and sometimes just, it does help prevent accidents, even if those accidents are really, really stupid. So, yeah. Oh, and I guess one concern for a lot of people would be like, oh, this board only has a single 4-pin power connector. This is still capable of delivering at least 240 watts to the CPU because, basically that connector, the power lines for ATX power supply are 10 amps per cable, and these connectors are rated to do 13 amps per pair of pins, as in one in, one ground. So this is perfectly capable of delivering 240 watts to the CPU. And Kaby Lake at 5 gigahertz is about 150. Actually, it's less than that, depending on what CPU you have. So, yeah, that 4-pin really isn't a concern. It's more of a case that all the motherboards that come with like an 8-pin, or, some overclocking boards for Z270 come with 2 8-pins. Those are just ridiculous overkill for no apparent reason. It's really like, yeah, a single 4-pin is enough. Arguably, a 8-pin or 2 8-pins would, help get cleaner power delivery, but Kaby Lake really doesn't need that much power, so I don't think it makes a huge difference. I will not be bothering with modifying this. I'll just run a single 4-pin. So, yeah, that pretty much covers everything I want to cover on this board. I mean, It should clock memory better. The VRM is not great, but it's enough. It has a... Oh, that's actually interesting. It does have a separated audio section down here. That lights up with LEDs. What else is there? Chipset VRM over here. Not that it matters because you won't be overvolting or overclocking the chipset anytime soon. You do get a PS/2 port, which is nice for, you know, overclocking. And, well, legacy OS support and, you know, just general overclocking. So, yeah, I mean, my overclocking experience with the motherboard so far has been really, really good. It recovers very well. Gigabyte, of course, has their typical dual BIOS implementation, which we have BIOS chip 1, BIOS chip 2. So, you know, you have dual BIOS on the board. So, it is very, very easy to work with the board. One thing I love about Gigabyte's BIOS implementation is if you clear the CMOS, the BIOS automatically saves a last known good profile for you. So that's useful in a situation like, say, I was testing 5 gigahertz and I got the memory running at 3600 very, very easily. And then I was testing things like 3733. And 3733 was doing this weird thing where it would just like, it would post, but it wouldn't boot up at 3733. What would happen would it would downclock the memory to 3466. So I would get all the way to the BIOS to find out it's at 3466, which is fine, because that's not really a problem. I mean, I don't have to, like, I'm more annoyed if the motherboard keeps boot looping than if the motherboard boots up with the wrong settings, because that means I can fix it. If it keeps boot looping, then I need to, you know, get into the BIOS somehow, and that'll usually include a clear CMOS. So if you screw up your settings a lot and they're completely unstable, the motherboard will just get you back into the BIOS on reduced settings. If you screw up your settings in such a way that they're just about bootable, then this motherboard boot loops, because it almost manages to load up the settings, then it fails. Doesn't get anywhere, so you have to reset, and it almost gets into the BIOS, but fails, and you have to reset. And that causes a boot loop. So in that boot loop situation, which occurred to me when I was just about getting, I think, 3866, I was almost able to get 3866 running eventually. And when I was working on that, the board boot looped, and so you clear CMOS, and due to the Gigabyte's, you know, BIOS implementation, which remembers your last known good settings, once I got back into the BIOS, which was now completely cleared, I went to the save and exit tab where you have all your profiles listed, and then you go load profiles, and there will be a profile automatically saved for you called last known good. You click on that, and it loads up the last settings that you had before you cleared CMOS. That means if you're going to be clearing the CMOS, clear it once only. Okay, and you do clear by short-circuiting those two. You clear by shorting out these two pins. So if you're going to be clearing CMOS, you know, clear once. Don't clear multiple times, because if you clear multiple times, then you destroy the last known good settings. If you clear once, then your last known good will be there. So you do need some level of certainty, you know, with your shorting. If you accidentally double tap it, your last known good is gone. Well, is very likely to be gone. So yeah, but it is a very, very nice, you know, feature to have, that the BIOS automatically basically saves a profile for you, so that you don't have to go and, you know, change a setting, save a profile, reset. You just go change a setting, reset, change a setting, reset. And when it starts boot looping on you, you can clear CMOS, and you can start off literally on the last settings that you tried before it started boot looping. So that's really, really nice. And Gigabyte actually has this on most, I think, all of their boards now. I mean, even my 990FX-Gaming has that, but yeah, you know, I like the board. And yeah, there's not really much else to say at this point, so let's wrap that up right here. So I would like to thank the Patreons for making it possible for me to actually get this board, because I did have to buy this one. And that's partly sort of moral reasons, and just like it's stupid to turn up with a free sample to a competition to win more free motherboards, especially if that free sample is from the motherboard manufacturer. So it's sort of a case of, like, you know, buy the board for that reason. The other thing I would like to thank all the Patreons for is the 7700K, because I wouldn't have one without you. So thanks for making those possible to acquire, and in return, you'll get a review of this board as well as this video, as well as this motherboard in a bunch of live streams. So, don't kill me for not buying a Ryzen board. But yeah, so thanks to the Patreons. And at this point, it's a case of you should subscribe if you haven't. If you have subscribed, then I suggest you press that notifications button. Sign up to the notifications, because I do want to start releasing more than one video a day. And when I start doing that, then YouTube's subscriber inbox thing is completely broken. It'll basically only tell you about one of the videos, not both of them, if they're released within less than 24 hours of each other. Which, I don't think you want to miss any of my content now, do you? So I suggest joining notifications. And if you have any questions or comments, or, well, there's a comment section down below, so you can use that. Thank you for watching, and see you next time. Oh, wait, nope. I forgot one thing. There are shirts. AHOC shirts are now available. You can, well, for Europe, not for the US. I'll set that up later. So basically assume that the US will be available by the time the video goes up. Or just check back whenever, Shirts are going to be available from now on until eternity, or Teespring stops working, Well, the shirt supplier goes out of business, but yeah, so that's that. So thanks for watching, and see you next time.